Okay, now let us go back to this formula. So this formula works if A is a 2 by 2 matrix. Question, is it possible to generalize it? The answer is yes, but now generalization is kind of tricky. Part number 1 is same, 1 over determinant. But part number 2 is kind of convoluted. We have some C's. Well, T means transpose. But what are these C's? It is easier to explain what are these C's using the following example. So, we want to find inverse of this matrix. Step 1, let us find its determinant, and I show you steps in the appendix. Determinant of this matrix is 27. Now, how do we find C's? Well, the formula for C's is written. It's -1 to I plus j times determinant of aij. We can say, okay, number 1 looks complicated. Number 2, who are these aij's? Well, once again, please take a look at the example. In order to obtain a11, we delete row number 1 and column number 1. What is left is 5, 6, 8, 0. It's exactly what is written here. In order to find a12, we delete row number 1 and column number 2. What is left is 4, 6, 7, 0. Done. In order to obtain a13, we delete row number 1 and column number 3. What is left is 4, 5, 7, 8. Done. Next step, we find determinant of each matrix. So now the process is much longer. Lastly, in order to find C's, we multiply these numbers by alternating signs, starting from plus. -48 times +1, same number, -48. -42 times -1 is +42. -3 times +1 is again same -3. We keep going. So we do H1, H2, H3. And now in order to jump from here to here, we start with -1. So here we change the sign. Here we do not change the sign. Here we change the sign. And so on. Here is the result. And then we transpose. By the way, a highlight T. Very often students forget to transpose. And the result follows. Folks, any questions here?
Professor, is there any reason you do one kind of solution versus the other for a certain example?
Yes. Very often students ask me the following question, very natural question. Which approach, which method is better? Well, guys, it depends. So there are no clear-cut recommendations. Please take a look at what happens if we find the inverse of this matrix using approach number 1. We put together AI and then apply elementary row operations in order to get I on the left. Observe that at some point we get fractions, and it's really hard to deal with fractions. Therefore, for this particular matrix, I would say a method number 2, the formula, is better. But it all depends. It all depends. I would say for this matrix, method number 1 is better. So in other words, in some sense, if the entries of our matrix are relatively simple, method number 1 is better. But think about, especially if entries of our matrix are crazy, like pi, cubic root of 7, 100 factorial, and so on. It's really hard to do elementary row operations. So method number 2 is better.